It's fine. All right, so let's talk about how to solve log. If I was going to ask you to solve this equation, how would you go about doing it? Well, another way of writing this equation is I can write it in log form. I could say the base 3, log base 3 of 5 is equal to the exponent. But here, I know how to solve that. I can just crunch that through a calculator. So I get 1.46 equals x. And so in order to solve it, I can just do it kind of directly here. I can rewrite this exponential as a log function, and then I can solve it because I know how to do this. The second thing you can do is a valid operation you're allowed to do is if I have 3 to the x equals log of, oops, hold on, 3 to the x times 5, I can, taking the log of 3 to both sides is a valid operation. It's something I can do because here, if I have the log of 3 of a equals the log of 3 of b, I can safely say that this implies that a equals b. So if log of 3 of a, so if these equal each other, then a equals b, right? This is a safe thing to say, since there's a reason this is safe to say. Log is a one-to-one function. We didn't get into that, but just understand that you can take the log of both sides. So if I take the log of both sides here, log base 3 of 3 of x is just x, according to our rules. And then here I have log base 3 of 5 again, which is 1.46. Okay, so we can do both of these. All right, so what do we have here? So isolate, so guidelines, so these are guidelines. These aren't, what was it? Was it the, what's that movie? Pirates of the Caribbean. They're not really rules, they're more like guidelines, right? Same thing here. They're not exact rules of how to solve it, but guidelines of what to do. So the first thing you want to do is isolate the exponent to one side of the equation. 2, take the log of both sides. And then 3, solve for the given variable. So let me explain what that kind of looks like on a couple of these. All right, so here, have we isolated the exponent to one side or the other? Yeah, so 1's already done for us. 1's done. 2, we're going to take a log to remove the exponential. So which log am I going to take here? I'm going to take a log of 4, right? So I'll take log base 4 of 4 to the x minus 2 equals log base 4 of 15. Okay, well, log base 4, so log of 4 raised to some power means it's just x minus 2 if you remember your rules, right? So these are inverses, so they cancel each other. And then log base 4 to 15. So we're going to just leave that as log base 4 to 15, or 15 right now, and just take x equals log base 4 of 15 minus 2. You just crunch it through any calculator you like. For these, we're going to round to 2 decimal places. On the exam, you round to 2 decimal places. Okay. So this would be 3.95. And so that's how we solve this one. Here, if we're going to do this one, there's a couple ways of doing it. One, let me actually show you both ways real quick. So here, we've isolated the exponent, kind of, sort of. The best way to do that would be write e, multiply this in, so 3x equals 15, and then we take the natural log of both sides. So e, natural log of e, would give me 3x. So ln of 15, and then we'll just take x divided by ln of 15 over 3. And so there we go. Or another way of doing this, if I just take ln of e to the x plus times 3 equals 15, I can pull this out. I'll get 3 ln e to the x equals 15, which gives me 3x ln, oops. This should all say ln 15. ln 15, ln 15. And it ends up working to be the same number. Yeah, I screwed up. Sorry about that. Okay. All right. Okay, so let's do this one. So step one. So step one, is this exponential isolated? The answer is no. So we're going to do that first. So we're going to minus 10 from both sides. So we'll get x to the 4x equals 55. Then we're going to divide out the 5. So e to the 4x equals 11. And then we can take, so now we can do step 2, take the log of both sides. So we'll get 4x equals ln of 11. So we get x equals ln of 11 over 4. And if I crunch through that, I get roughly 0.6. Oh, I forgot, these are rough numbers. I actually never crunched this number, did I? That's fine, I'll go type it in. I have some of them pre-crunched. Apparently I never pre-crunched that one when I was making my notes. I'll crunch this as I have you do that. So go ahead and try C. Try C. So C, go ahead and write it in terms of pi. Actually, give me the rough answer. Give me the rough answer. Actually, go all the way through. So 1, you're gonna have to isolate the exponent, right? So you're gonna want this. Here I have this. There's something you can do to make this easier for you. And then 2, take the log of both sides, whatever log you want. And then 3, solve for a variable. So go ahead and give this one a try and see what you get. And I will pull up and crunch that number real quick just for my own sanity. Ooh, hi. We're from Alpha. All right, ln 15 divided by 3. Boop-de-doo. This is approximately 0.90. You can give me the answer either in exact form or approximate form right now. What we mean by exact form, this is exact, this is approximate. And approximate has these little, this means prox. I don't know if we've actually addressed that yet. It means approximately equal. It means we've rounded. All right. Has anyone got an answer for this one? Not yet. This will gauge if I need to do extra problems with you guys or not. And I'm guessing at this point, probably yes. Not entirely sure where to start. So yes, someone did get the answer. All right. Let's do this slowly. Let's do this slowly. I'll probably do. All right. So here, I want to isolate the exponent, right? I want to isolate the exponent to one side of the equation. So here, if I multiply pi to the x times pi to the third, I can just add up the exponent. So I get pi to the x plus 3 equals 30. So I gave you the first step. I'll see if some more people can crunch here and give me some answers. Does that make it clear how to start? Yes, no, maybe. I thought you kind of. Okay, let me just do this one. I'll make up some more and we'll do some more. It's fine. That's fine. Let me do a bunch of examples so you can see. Then we'll have you crunch. I will just make up a bunch. All right. So here I can combine it. So I always want to have something raised to some power, right? For the exponentials, right? That's the goal. Something raised to some power, and then everything else on this side. So this is just everything else. So here, I got e to the 4x, e raised to some power, and everything else was on this side, right? And luckily, this time it was a number. Here, I wanted something raised to some power, everything else on this side. So this one's already done, right? This one, I wanted something raised to some power. In order to do that, I actually had to do my exponential rules to get it look like this. This one's a disaster. This one's a disaster, and you know what? We're not going to do this one for this class. This one we're not going to do. This is in the homework everywhere on the online homework. We're not doing this. It's just not useful. I taught it for the homework only, except I'm writing your guys' homework, not using the book's homework, so we're skipping this one. So once again, you always just want something to look like this. How to do that one, just to show you. How you do this one is you play this little game of exponents and you solve it, and then you can solve two different things. Don't even worry about it. Legit, don't worry about it. Okay? I've only done problems like this teaching this class out of this book. That's it. Because if later on you get better techniques to solve it, and then that's when you would encounter it. So let's go back to it. So the whole goal here is to make it look like some exponent to that. Then we're going to take the log of whatever this base is. So here I'm going to take log of pi to the x plus 3 equals the log of pi of 30. Log base pi of 30. Log base pi of pi raised to some power is always just that power. Right? That's why we went over those rules 2 days, yesterday we did these rules. And here, log base pi of 30 is just some number. So this is log base pi of 30. And then I have log base pi of 30. And then I'm going to just minus out 30 minus the 3. So that's the exact answer. That's the exact answer. And then we just type in here. And I think I can just type in log base pi of 30. I want to see how smart it is. How good are you? Yes, I had a feeling it might do that. All right, so you're gonna have to be a little bit more explanatory to the program. 30. See if that helps it. There we go. Yeah, and then here we get minus 2.2882, so it's roughly as Isabella got it, which is x equals minus 0.03. All right, let's see what we got here. I put that in my calc. Okay. How to put that in your calculator? If you're gonna type this in a normal calculator, you're gonna type in log of 30 over log of pi minus 3. That's what you would actually type in. Well, actually, what you really type in would be log of 30 divided by log of pi minus 3. And your calculator should be smart enough to do order operations to capture that. All right, so let me give you the hardest thing we're going to do, and then I'll just make up a couple more problems. All right, so here we're going to have, we have two different bases, right? Here we have 7 and we have 3. You can solve these. In order to solve these, you're just going to take the log of both sides, but it doesn't really matter what log we take. So we're going to just take the ln of both sides. So log of 7 of 2x equals the log of 3 of x plus 2. Then, once I've done this, these ones are kind of unique. Then once I do this, what I'm going to do here is I can now use my log rules to pull my exponents out front, right? Remember we could do that? So we'd have 2x ln of 7 equals x plus 2 ln of 3. So what did I do here? I realized that these are different bases. So I just took any log at all, any log at all. So here I'm just choosing ln just because it's easier to write down. Literally the only reason I chose it. Then, after doing that, I can use the log rules to pull my exponent where my variable's at out front. Exponent variable out front. ln of 7 is what? It's just some number, right? It's some number. Do I know what that number is? No, but I don't have to care about it right now. This is some number, right? So I have 2x times some number plus x plus 2 times some number. So let's just kind of crunch through that just a little bit and simplify it. So here I'll get x times 2 times ln of 7, because this is still just some number. Here we're going to distribute this in, so I'll get x times ln of 3 plus 2 ln of 3. So here I'm just distributing the ln of 3. So what do I have here? I have x times some number, x times some number, plus some number. Well, how would I solve this in the old way? I'd just move all my x's to one side. So here I'll have x times 2 ln 7 minus x ln of 3 equals 2 ln of 3. Well, here I can just pull out the x, so I'll have x is equal to 2 ln of 7 minus ln of 3 equals 2 ln of 3. And then we can have here x is equal to, oops, that's that, 2 ln of 3 divided by whatever this number is, 2 ln of 7 minus ln of 3. And then I can just type, so this is the exact answer, and I can just type that roughly into a calculator and get 0.78. Okay, we'll do at least another practice that looks like these two once we finish the notes. Let's just do it now. Let's just do it now. We still got a half hour. That's plenty of time to do the other sheet. So let me just open up a new window. La la. All right, so I'm gonna have you guys try two things. So we're gonna do, I don't know, 2x plus 2 is equal to 5x. Yeah, so I'll have you guys try this one, and then we're gonna try 4x cubed minus. Here, start working on this one, because this one's just gonna be awful anyway you cut it. And let me make sure I can get this one to come out somewhat nicely. Okay, and then go ahead and work on this one if you finish the other one. So let me know what you get for the answers for these. So give them a try. Actually try to crunch through it. This is super important. So actually just do it. So the first thing you're gonna, so on this one, so just take the natural log of both sides. It'd be the first step you would do. Okay, so just take ln of both sides. It'd be the first step you do. The first step you would do here is to get it. I've lost my little mind, haven't I? This needs to be the other way around. All right, let me fix this problem. Like I said, work on that one because I apparently can't write problems right now. Yeah, this. There we go. All right, you guys having any luck at all? 1.5. You know, I legitimately don't know what the answer is. We have two people with answers. If I get a third one, I'll crunch through it. I can crunch what the answer is right away, though. What is it? Yeah, this is me not being able to spell. Anyone else get an answer for the first one? Yes, no. Did everyone just space out? 1.5. Okay. So yeah, that's the correct answer. So let's figure out how we got there. So here we'll have log base 2 of x plus 2, and then we'll have log base log of e, so ln of 5 up to the x. Here I can pull this out front. These always run the same. 5x plus 2 times ln of 2 equals ln of 5, or x ln of 5. Move, and then here we're just going to distribute. So I'll have ln of 2x plus, I'll write it this way. So some number times x times ln of 2 times 2 equals ln of 5 times x. Technically, if you crunch in the numbers here, you could run it through, but it's safer just to wait to the end. So we're going to move stuff over. So I'll have ln of 2 times x minus ln of 5 times x equals, I guess I could have moved it all one direction. It doesn't matter. Then I might as well just do it. Minus 2 ln of 2. That gives me x equals minus 2 ln of 2 divided by ln of 2 minus ln of 5. And if you crunch this through a calculator, you get approximately 1.151. Okay. This is a negative number, which will cancel this negative number, and so that's where it comes from. So that's how you do any of these problems, is you just pop out the exponents and then solve through. Okay. Has anyone tried this one yet? 3.25? I think that's right. So let's crunch through it. So here, I'm going to take, so here I want to isolate this. That's my first step. My first step is isolate this. So I'm going to isolate this. So I need to move 3 over. So I get 4 minus, or 4 times 2x equals 38. Divide by 4. So I get 2x to the x equals x to divide this by 4. It doesn't do it super cleanly. It's fine, just leave it right there. So here I'm going to take log base 2 of both sides. Log base 2 of both sides. Since this is single x, it'll just be x. So it would be log base 2 of 38 over 4. And if you crunch that through a calculator, we get log base 2 of 38 divided by 4. You get x is approximately equal to 3.25. Okay. All right. So these are, you'll see something like either this or this on the exam. So you see either this one or this one is what you'll see, roughly. So let's talk about the next set of things we need to do, and that's to solve log equations. I'll do about 4 with you, and then I'll have you guys try one. And then tomorrow we'll ask a lot of questions on this. So let's pretend I wanted to solve this real quick. If I wanted to solve through this, oh, it's not much. If I wanted to solve through this, I'm going to use the fact that if I take 3 raised to a equals 3 raised to b, then a equals b. Okay, so we're going to use this property. Once again, because exponentials are one-to-one functions, we're allowed to do that. So here I'm going to just exponentiate both sides to the power of 3. So I'll have 3 times the log of x minus 2, and then 3 to the 2. So here I'm just taking a and b and just making them exponents. So 3 raised to this, we'll actually just bump out this again. So I get x minus 2. 3 squared is going to give me 9. So that means x equaled 11. Right? I'm going to add the 2 right on the right there. So here, we're going to do the same thing. We're going to try to exponent the, oops, I shouldn't say exponential. These should say logs. Let me fix my notes. I'll have to reload them. These both say logs. Sorry about that. Apparently there's some errors in these notes I type up. And isolate the log function to one side of the equation. Take the exponential to remove the logarithm. Solve for the variable, and then check in the domain. So this is a new step. So you have to do this. You have to do this. This has to happen, right? If not, you're going to get wrong answers. Okay. So let's explain how we did it. Let's just crunch through a couple of these. All right. So here. So if I have log base 5 of this, I'm 13 minus x equals to 2. First thing I want to do is exponentiate both sides. So I'm just going to say 5 log of 5, 13 minus x equals 5 raised to the second power. So here I'm just exponentiating what's all of this to one side, all of this to another side. Once I do that, because of the rules of logs, these cancel, so I have 13 minus x. This becomes 25. So I get minus x equals 12, or x equals negative 12. Okay, so same thing here. Here we're going to try to get this. Here we're going to want to isolate the log to one side. So the first thing I'm going to do is move over the 3. So I have 2 log of 4x minus 3 equals 8. So minus 3 to both sides. Then I'm going to divide out the 2. Now, could I put the 2 in here? Yeah, but then it'd make this awful. So let's just divide it out. There, it would give you a correct answer. It'd just be a rough way of doing it. Because then this is just 4. So I have log base 4 of this. My shorthand notation is just to put a big 4 here and a big 4 here. That means exponentiate both sides. So here, log base 4 raised to log base 4 would just give me whatever this is because of their inverses of each other. 4 raised to the 4th power is 256. So if I minus the 3, this becomes, or add 3 to both sides, I get 259. Okay. All right, now we get into why we had to have our rules in the first place. So here I have log of, so log of nothing. So for us, that is 10, or well, not 10 factorial, but it's 10, right? So this is the same as a log of 10. So here I need to isolate the log of both sides. So I need to combine them, kind of like how we had pi to the x plus pi, or times pi to the third. We have to put them together. Here we have to put these logs together. Well, if I put these logs together, how do I do that? Well, I just multiply it, right? I just multiply what's inside. So I'll have like, I'll write 10 just. So it'd be x plus 2 times x minus 1 equals 1. So now I've isolated the log to one side. Here I'm going to exponentiate it by 10, because that's what the base is. So I'm going to get just what's on the inside. So x plus 2, x minus 1 equals 10. All right, now right here, you're going to be sorely tempted to do something. Don't do it. Legitimately don't do it. And let me explain what you'd be sorely tempted to do. You're going to say either x plus 2 equals 10 or x minus 1 equals 10. That's not true. It's not even remotely true, right? If this was 0, yes, you can do that, because if two things multiplied equals 0, either one was 0 or the other is 0. If two things multiplied together were anything but 0, that can mean they could be anything. So don't do that. So in order to solve this, we're going to actually have to expand this out. So we'll have x squared plus 2x minus an x, so it'll be plus x, minus 2 equals 10. So that means x squared plus x minus 12 equals 0. Now that we have the 0 here, we can factor again. This will be x plus 4, x minus 3, because I want the factors of negative 12 to add up to equal 1. 0. Now we can do this. Now we can do this. That means x was either minus 4 or x was equal to 3. Does that make sense? So once we get it to this point, this is just solving an equation. So you should be safe at this point, but fight the urge to split it before then. Now we get to here. So what's our very last step? So we need to check if it's in a domain. Have I done this before? The answer is no, but let me just do it real quick. So x equals minus 12. If I plug in negative 12 way back into here, I get log of 12 minus a minus, so log of 15. So that's okay, because this is a positive number. Here, if I have x is 256, so I plug it way back into here. 259 minus 3 is still positive, and so we're fine. Let's go to here. Here, if I have log of 3, plug it way back into here, I'll have 3 plus 2, that's still positive, we're good. I have 3 minus 1, that's still positive, we're good. So this one's okay. But this negative 4, if I plug it way back into here, negative 4 minus plus 2 is negative 2. Can I take log of negative 2? No, that's outside of its domain, right? And here, if I have negative 4 minus 1, that's also outside of its domain. So here, this is not in domain. Not in domain, so it's not the answer. So the only answer here is this. This is the only answer, x equals 3. So you have to check that this is positive. And just a quick reminder right here on the side, log of a function of x, whatever that function is, that means that f of x was strictly greater than 0. So in this case, just for this one, so if I have log of x plus 2, that means x plus 2 is strictly greater than 0, or x is strictly greater than negative 2. Okay, so that's what the domain is. Whatever the function is, has to be strictly greater than 0. All right. So let's do this one. Here, do I have the log isolated? Yeah, I could take And if I wanted to, I could raise both these to the second power, and I can have x plus 2 to the third equals 2 to the ninth and solve this out. And it's a disaster. You can do it, but it's a disaster. What's easier to do at this point is here, if I have a cubic here, I can just pull this out and say 3 log of 2 of x plus 2 is equal to 9. So I have log of 2 of x plus 2 equal to 3. Then I exponentiate both sides. I get x plus 2 is equal to 2 to the third is 8. So x equals 6. There we go. And is this in the domain? Yeah, it's in the domain. So we're good. Okay. So this one's good, and this one's good. All right. So let me make you one problem, I guess, for this, for you to crunch on, just to try it before you guys do your homework. So this is how you solve log equations. There's a lot of examples. I'll upload the video of this shortly with everything else, and so you should have it before the end of the night. Hopefully I'll get them up before 3 o'clock, but we'll see how it goes. Uploading last night just did not end well for me, because when you upload to YouTube from my computer, if my internet like hiccups for a second, it says upload failed, then you have to wait another hour for it to put up the gigabytes of information, because hour-long videos take a long time to upload. Let me have you guys work through one. So let me just go back to my little blank sheet of paper. Where'd my blank sheet of paper go? Oh, we'll just clear it out. Let me make one. Let me make one that's not going to epically fell on you. So let's do log of 2 of x plus 2 minus. Let's not do that. Log of let's do that. That might be too rough. Let's get rid of the 2. Let's just have log of x. This should make it easier for me. Hold on. Can I make this come out to a nice whole number? Probably not. Let's just put it. Let's not put something that high. Let's just put a 4 here. Okay, so solve this. So give this one a try. All right, my internet has the same problem because somehow I found that every hotspot. Yeah. All right, so you can take the exponent. Yeah, I was right. Yeah, you can take out the exponent. All right, let me see if this comes out to be viable. Let's give it a try. We may have no answers. It is possible for me to write a log question that has 0 answers to it. This one should, though. Oh, it has an answer. It's a disgusting little thing, but it does have an answer. So, you're also recording. Do you guys know how to start the problem? Everyone's crunching away. Uh, 2/15. Close. Sadly to say that this ends up being a little bit uglier than I hoped it to be. Okay, since we only have like 5 minutes left of class, let me actually just crunch through how we do this. You should have at least attempted it, because if you attempt it, you can get to the point where you're confused, and then you can ask better questions. Okay, so here, the first thing I want to do is combine them, right? So I'm going to have log of 2 of x plus 2 times x equals to 4. And then I'm going to exponentiate both sides to 2. So here I'm going to get x plus 2 times x equals 2 to the 4th, which is, I think I'd have these memorized by now, 16. Okay. Okay, so then once we do this, we can just write x squared plus 2x equals 16. And then we'll have x squared plus 2x minus 16 equals to 0. Sadly, I don't think this doesn't factor cleanly, right? But if I just type it into Wolfram Alpha, it should give me a nice clean answer. Minus 16 equal to 0. All right, so here, once we type this into Wolfram Alpha, I have this, and so here, they're just going to use quadratic formula to solve this, right? So we get these two solutions. So square root of 17 minus 1 or square root of plus 1. The way this crashed out is here you're going to do this by hand. This would be minus 2 plus or minus square root of 16 squared minus 4 times 4ac. No. This would be 2 minus 4 minus a, so times 1 times negative 16. What am I doing? All over 2. This will pump out negative 2. And then once you solve this down, you're going to get x equals negative 1 plus or minus the square root of 17. Oops, 17. Or you type it in a calculator. I'm perfectly okay if you type it into a calculator. Yes, and so we have these two answers. Now we have to be very careful. These are, what are my domains? So my domains here is x has to be strictly greater than 0, right? And here x has to be greater than minus 2. Remember how we got to this? This x plus 2 has to be strictly greater than 0, so x here has to be this. Notice that this one trumps it, so we just have to have all our answers to be positive. Square root of 17 is roughly 4 in your head, so negative 1 plus 4 would be okay. So x minus plus the square root of 17, that's okay. But if I have 1 minus 4, that's going to be negative. And so that one, so the x equals to 1 minus, or negative 1 minus the square root of 17. This one's not going to be in the domain, so we have to throw it away. Okay, so this is the only answer. All right. So class is over in 2 minutes, so go try the homework.